This is a really hastily put together video on how to use Excel for the systematic treatment of equilibrium. So here were the equations we came up with in class. There are 8. We're solving for 8 different variables. And we're going to use our charge balance equation as our base equation. So what we have to do then, if we're using H plus as our target variable, is we have to replace everything in this equation with something as a function of H plus. So sodium and chloride we have actual numbers for, so let's plug those in. And then what we need to find is we need to find these other 3 variables in terms of H plus. So here are the equations that we haven't used so far, and we manipulated these in class, and we found that we can use this equation to come up with an expression for OH minus. We can use these 2 equations to come up with a formula for OCl minus, and then we can use these 2 equations to come up with a formula for acetate. So we can now plug those all into our charge balance equation, and we get this. Here I've rearranged the equation so everything is on one side and it all equals 0. You'll see why we're going to do that in a minute. And then we are going to simplify it further by combining these. And so we get this equation, and that's what we're going to use. Never mind those equations. We're going to transfer this to our Excel spreadsheet. Okay, so here I have a spreadsheet that I've made up in preparation for my calculation. And just as a reminder, our equation that we're using is down here at the bottom of the screen. Now, in column A, I have put the pH. You don't have to put the pH, you can just go straight into H+, but it is a lot easier to enter pH, and so that's why I'm doing it that way. So I'm going to make a column for H+, and remember that H+ is 10 to the minus pH, so that's what I'm going to do here. We're going to make a formula that calculates H+, and again, anytime you use a formula in Excel, you have to start with an equal sign. Don't forget that. So this is 10 to the minus pH, so we're going to do 10, and anytime you do an exponent, you're going to use the little caret sign. And then I am going to put minus pH, so -1 times pH, and I'm just going to click on the cell with pH, close the parentheses. So this is 1 times 10 to the minus 3rd. And now that I have the formula in, I can click and drag it down. The second term in our formula is just 0.1. And so I'm just going to put in 0.1. That's easy enough. The third term in our formula is minus 10 to the minus 14th divided by H+. So equals minus, and I'm just going to put 1e minus 14 for 10 to the minus 14th, divided by H+. And let's click and drag that down. Our next term is this minus 0.05 times 10 to the minus 7.53 divided by H+ plus 10 to the minus 7.53. Here, things are getting a little complicated, so be careful where you deploy your parentheses. So equals minus 0.05 times 10 to the 7.53 divided by, and here we have a sum in the denominator, so I'm going to put the whole thing in parentheses, H+, so that's this cell, plus 10 to the, and again, let's put this in parentheses, minus 7.53. The final term in our equation is the one that represents the acetate anion, and that's minus 0.10 times 10 to the minus 4.75 divided by H+ plus 10 to the minus 4.757. Okay. Now, if you look at our equation, again, you'll see that when we add up the 5 terms in this equation, they should add up to 0. So what we're going to do is we're going to add up all these terms and see what they add to. Now, there's a couple ways you could do this. You can, let's do equals for start, equals this plus that plus that plus that plus that. It's one way. But the way I usually do it is I actually use the sum function. So equals sum, you always have to use equals, even if it's a built-in function. And then you can just click and drag for the cells you want to add up. There we go. So now we can cut and paste that down. And what we're looking for is we're looking for the pH in this table where it's the closest to 0. Now, that's kind of hard because we have some things that are above 0 and we have some things that are below 0. And it's actually easier if you do the sum squared. So we're just going to take this and we're going to square it. And then when we do that, all of our numbers will be positive and we can just look for the lowest one that we see. And when I'm looking, so I'm looking and I see 10 to the minus 3. Here's 10 to the minus 3, but we have 10 to the minus 4 here and 10 to the minus 5th. So this is the closest one, this one right here. So pH 6 is the closest. It's going to be slightly acidic. So the question then becomes, is it exactly pH 6? Or is it slightly more acidic than pH 6? Or is it slightly less acidic than pH 6? So this is why I use the pH. We can now enter pHs that are close to pH 6, so like 5.9 and 6.1. Let's cut and drag these down. So this is the one we're trying to beat, 1.58 times 10 to the minus 5th. If we do 5.9, we see that the sum squared is 3.1 times 10 to the minus 5th, which is bigger. It's farther from 0, right? 6.1 is 6.51 times 10 to the minus 6th, so that's smaller than this. Great. This is the new pH to beat. So now we want something that's more basic than 6. So let's try 6.2 and see what happens. 1.55 times 10 to the minus 6th. That's great because that's even smaller than this one. Let's try 6.3. Ooh, 1.95 times 10 to the minus 11th. That's great. That's super small. That's the smallest yet. Okay, let's do 6.4. Oh, look, it's gone back up to 10 to the minus 6. So it's somewhere around 6.3. And now we can fine tune it even further by maybe putting in 6.29 and 6.31. Both of these are 1 times 10 to the minus 8th. So it's probably really close to 6.3. 6.305. That is definitely close. That's definitely smaller than 6.31. 6.302. That's 6.301. 6.18 times 10 to the minus. No. Let's try this. 6.299. Well, I think this is actually the closest. I'm going to call this pH the pH that it's going to be. pH 6.3 is going to be the pH of our final system. So this will be our H+, and we can use that to calculate all the other concentrations. Obviously, that's a lot of work, and you might wonder, does Excel have a built-in feature that might help us with this? And it actually does. The problem with that built-in feature is it doesn't always work. So what we're going to do is we're going to try using the built-in feature. And the built-in feature is found in the Data tab. I have a Mac. It might show up a little different in a Windows machine. So what we're going to use is we're going to use the solver. If you don't see the solver right here, you need to go to the Tools menu right here. Click on the Tools, and there are these Excel add-ins. So you can see I have already checked that, and that's why the solver shows up. So back to Data, Solver. Okay, so what we're going to do is we're going to set the objective cell, and I am going to use this one. Whichever one you use, I don't know why it's not letting me do that. You want it to be one of the sum squared ones. And so we want to make that as small as possible by changing what? By changing the H plus constant. Well, let's change the pH. I don't know why it's not letting me do that. Okay, and then you hit solve. Okay, so when I did it, it found this value right here, 6.30036. So it was really close to 6.3. And you can see that the sum squared is 1.64 times 10 to the minus 17th. So that is obviously a much easier way to do that. The problem is that for some reason, when you're working with really tiny numbers on the sum squared, sometimes solver doesn't like to work very well. And so it'll say, oh, you're at the best solution when you know that you aren't. So the way that I optimize that is I just keep changing the pH until I find something that's really close, like 6.3. And then it will usually get me a good solution. So this is our answer for final pH. This is our answer for H+, and we can now use that to calculate everything else.